The next tuning module we are going to talk about is the Asphalting model tuning. Asphaltene model in HydraFLASH is the PC-SAFT equation of state, and by tuning we mean adjusting and tuning the PC-SAFT parameters so that the model predict the given experimental data values as close as possible. So for example, when you're using saturation or AOP data, AOP stands for Asphaltene Onset Pressure. So when you use any experimental data, the model parameters, HydraFLASH, tune those model parameters so that model produce those data, or at least as close as possible. So again, as mentioned before, in order to perform any asphaltene calculation, the fluid must be characterized using SARA fractionation analysis. So if you have the SARA analysis, you can characterize the fluid, and then when the fluid is characterized, it can be fed into asphaltene model tuning and any asphaltene calculation. However, it is important to remember that if you directly use the characterized fluid in asphaltene calculation, the result cannot be reliable. The reason is that asphaltene is a very complex fluid, and or it's a solid, and each asphaltene precipitated from different oil samples around the world is different. So there is no general universal model which can predict the AOP data or any other data with a good accuracy. So all models, they need to be tuned with an experimental data which has been taken for the fluid that is being used for asphaltene predictions. Okay, so when you characterize a fluid with asphaltene characterization, you can activate it in this module, in this window. This is the main window of asphaltene model predictions. You can use different experimental data for tuning. You can use AOP or upper or lower onset pressures, which has been measured with depressurization method, or you can use saturation properties or titration. Titration, as you know, asphaltene precipitation is governed by two different methods. The changes in the pressure or temperature of the system and the changes in the composition of the system. The depressurization method changes the pressure of the system, and then when the first asphaltene deposits, that's the position of that's the pressure of the AOP, and the titration is used in the lab using normal pentane or normal heptane, and by changing the composition of the system, the precipitation will be measured. You can use saturation, AOP, and titration, or a combination of these data to tune the model with. The only thing you need to do is to choose the proper tab, enter the data, and press start optimization. And then HydraFLASH will start to adjust and perform the optimization and tuning procedure. And when it is done, you can save the model, the new fluid, which its parameter has been tuned with experimental data, and then using that tuned fluid, you can perform any asphaltene calculation. So again, to summarize it, for asphaltene model tuning, you need to characterize the fluid using SARA analysis. Then you need to look which data you have, and then enter the data, tune the model. Then when the fluid is tuned, the model is tuned, then you can use it for any asphaltene calculation. Okay. Now I want to show you how you can tune the asphaltene model, the PC-SAFT equation of state, parameters using some Asphaltene experimental data. To tune Asphaltene model, as again mentioned before, you need to first characterize the asphaltene fluid, the fluid with SARA analysis using this module that you have here. So you enter the single flash data, the SARA analysis, and the composition of the flashed gas and the dead oil. You characterize it, and then the characterized fluid can be saved on a database. To have more information about how to characterize it, please refer to the characterization videos. Okay, to tune the model, go to the calculation tab, and in the Asphaltene modeling section, press Asphaltene model tuning. Okay, as mentioned, you have several options: the saturation, AOP saturation, titration saturation, and titration AOP data. You just need to enter select and activate the fluid which has been characterized with SARA analysis, and then just simply enter the AOP data. So I don't have any AOP data for the composition for the Pedersen book composition, but I just enter a random number just to show you how you can tune the model. So AOP data, I assume that this fluid has an experimental data which is at 150 degrees and 200 bar, and it's an upper onset data. If you don't know whether the data you have is upper onset or lower onset, you choose general onset data. But if you know for sure that it's upper onset data, please choose this one. Usually AOP data are upper onset data, and it is default. And the reason that if you know it is upper onset, please choose the upper onset is that it's faster. The tuning will be much faster. And then you need to select the characterized fluid and press tune button. As you can see, it's now optimization completed, and the time, it was 2 seconds, and they are the PC-SAFT parameters for the asphaltene pseudo component, and the AAD, which is very small. That means that the tuning has been successful. And then if you're happy with the fluid and you're happy with the suggested name for the new fluid, new tuned fluid, you can just accept and save it to database. You just press this button and it has been saved on a database. And I just want to mention something else. If for two type of fluids, you will receive an error if you choose and activate them. The first one is the fluid that you have tuned before. So if I enter data here, 150 and 230, and if I press, so this is the fluid that I just tuned. If I press tune asphaltene model, it gives me an error saying that this fluid has been already tuned with experimental data. So I cannot retune it. I just need to go to open the original characterized fluid and tune it with some other data. For example, titration and saturation. For the titration, saturation, or titration AOP, anything else, you can retune it. The other one is the uncharacterized fluid, the fluid that has not been characterized with SARA analysis. If you press to tune, the active composition has not been SARA characterized. Please perform a SARA characterization first. Okay. The other thing is the titration data. As you can see, titration, you have two options. the titrant can be normal pentane or normal heptane. And the titration databases is either weight or volume. What does it mean? It means that usually the titration data are reported by the volume of, for example, in this case titrant, the volume of normal heptane that has been used to titrate until the asphaltene starts to precipitate. They have the volume of the heptane, they have the volume of the tested oil, and that makes a fraction. And that fraction, they usually report that fraction. And the titration temperature is also important. If they don't report the titration temperature, you may ask the provider of the PVT report, or you can assume that it has been done in a lab temperature, which you can assume it's 90 degrees or 15 degrees or 20 degrees. It will be room temperature. And so you have, for example, for titration, if you have only titration and you don't have any saturation data, just leave the field blank. And same for titration and AOP. If you don't have the AOP, you can just leave it blank, and it tune the model using only titration data. But you need to remember that if you tune the model with only titration data or titration and saturation, it doesn't represent the AOP behavior of the system. So if you tune the model with titration data and saturation, and then plot the asphaltene phase boundary, and then compare it with experimental AOP, you may see a deviation. The reason is that the titration changes the composition. And when it changes the composition is something different than the original fluid, because you're adding more heptane or heptane to it. So it doesn't represent. If you want that the fluid, the tuned fluid, represent both titration and AOP data, you need to have both of them and tune the model with both of them.